Alrighty.
Hey, so since last time, uh, what I did was there got all the stuff moved over that we might need, all of these different stuff functions, but it turned out we didn't need them because the way that originally we were planning to call Mook was to use the wish arm, but we don't have a working version of that yet in Aries. So the decision was made after consulting with Joe that for now we should just get uh, version, just a version of Mook that runs entirely in Aries, and we can then use that to jet the Mook function later if we need to. But for now, we'll just unlock it. So now we have in the interpreter itself is jet for Mink. We have a special function for jetting Mook and hook it up. So I wrote a bunch of stuff for that. I started using less helpful daily messages because the stuff didn't really break apart cleanly, and Ed wanted me to stay pushing every day so people would have better visibility about what we're doing. So I
Yeah.
did that. But one thing that happened when I finished, mostly finished, I finished enough to get it unblocked. There's a bunch of XX to dos that we'll run into later, I'm sure. But the first thing was get it all working. And I started trying to run the pill, this one, the toddler.hoon with the playpen, building off of baby.hoon and the cradle. Um, so the idea was that I had this mutually recursive Ackermann function. This one will turn on the spot hints. It'll also have a mean hint here. Uh, yeah, it'll have a mean hint here, and then it has a hella hint here. A mean hint just is throw this onto the stack trace. A hella hint is print the current stack that would get printed if there was an error for a stack trace. And also a memo hint just to speed this up so later we can try testing this with much bigger values for the Ackermann function.
Yeah.
And I added another one here because I wanted to check, can we also nest enabling and disabling spot hints? So these are identical functions. They just call whack calls tack, tack calls whack. But the idea is that whack has enabled spot hints, tack has disabled spot hints.
Yeah.
So I tried to get this working. It didn't. When I started troubleshooting why, I messaged you about that yesterday, and I figured out that just a sufficiently old status branch would not work with the baby pill at all. And it just happened that the status branch from which I started making these changes was old enough that that happened. So eventually I figured that out and decided, okay, the next step is then to merge the most recent changes with Ed's new tree walking interpreter
Yeah.
into my changes. So I did that, and that involved, it's not really seen here because I did it all in the merge, but it involved adding a bit more code because there's like Ed's code, there's my code, and there's some more code to glue them together. But that's working. So right now, the situation that we're in is there's two different problems. So let me go back here. The first one is, so right now, if we turn the original foot effect that we had in the baby pill, inside
Yeah.
of this playpen. One thing I noticed in the playpen, quick tangent, is that I missed a bunch of stuff. There's a bunch of stuff that kept getting asked to put in. So I just decided, since we're not even going to use Mook of Wish, we don't need any of it. I just commented it all out for now. And then basically, playpen right now is almost identical to Cradle.
Okay.
So I decided to just call, when I was doing the first version of these tests, I wasn't even using the playpen, I was using the cradle as the hoon.hoon for the toddler pill.
Right.
So right now, if we turn off these slots here, and we turn off this printing the result out of a call to whack of the Ackermann function with n equals 2, n equals 1, and we just go back to the one that's in baby pill. So if we go here, it's the exact same one. And if we compile this, go back, so I'm going to copy over the playpen toddler. I'm going to commit it to the zod that I'm using. I'm going to rebuild the toddler pill. I'm going to, just in case, rebuild Aries. And and run the test to see if it's all working. And then I'm going to also, just in case, rebuild Urbit. This one's set up to run Aries as the serve. So I'm going to remove the existing fake dev ship. I'm going to call this build bear. Bad name. This isn't a script to build bear. This is the bear that I just built.
Right.
It's going to run dev. It's going to use the public build that we just filed. And there you go. It works.
Nice. Okay.
So now, go back. If we replace this one with either the slog or this thing that calls whack, we're going to get two different errors. One for if we have slog, one for if we try to use whack. That I would love to live debug with you. So this one will not even boot. This one, if we try to do slog test, so let me make that change and then again go over changes into the fake slot, compile a new public code. Oh, I see. I need about to. This one is going to be a different.
It just needs to return like x.poke or something. Yeah. Yeah. Get rid of the space again. On line 54.
Hey, oh yeah.
Yeah.
Good eye. I know I don't need both of them each time, but it's just a habit from when I did.
Yeah.
Okay, there we go. New one compiled. Let's clear it just in case. Recompile it. And then if we go this one, yeah. So we can clear this and try running it now. So this one has a memory allocation of 21 bytes failed.
Okay.
And then let me show you the other one, and we can hop into either one.
Yeah.
Instead of this, if we go back to this one, but now what the effect that we want to do is we want to poke the result of wax one. This add 48 is so that we get the, I think actually we need, this is supposed to be a list. I think we need this. The add 48 is to make it have the ASCII value. And I'm making this be a list, so it's technically a K.
I typically, by the way, write that as add like sock or something, like put like A or whatever the ASCII that we're starting with one. Like you can like so it's not a magic number.
You can do add 0.
Yeah, like that exactly.
Okay. So then again, we go back to here. Compile the pill. I'll leave this up and clear it. And this one has a bunch of hella fail, 2 not 2 calls, and then the here and the file.
Okay. Yeah, those both look like good ones to debug. I'd probably start with slog, just because slog is useful for debugging all kinds of stuff. So might as well get that running. Okay. Slog 0 test. That looks correct on its own. Really, we should debug by like directly, but I'd be curious. No, yeah, we should just debug directly. So we want to see how far it's getting, which we could do either in GDB or we can start sprinkling printfs. Printfs might be just easier. I don't know.
Currently not set up for GDB, so I think unfortunately we'll have to do printf debugging for now.
Sure. What do you mean by not set up for GDB?
Like I have not run it.
Okay, it should mostly just work if it's installed. I don't think there's anything fancy for like it. There is a like Rust extensions to GDB, which are not really necessary, but help us on the printing. But that's just cargo GDB or something. I think gets you to it. But printf debugging is pretty reasonable for this.
If you want, we could set up GDB. I have yet to have to use it surprisingly, so I just haven't set it up. That like I'm not set up to use it. Like I have yet to have to use it.
Yeah, it's really not necessary for this. What I would start with is just put a printf at the beginning and end of the slog handling to see if it's getting that far. Surely it is. And then also, is it crashing in the middle of slog handling, or did it mess up something somewhere else? Is it something about producing zero effects or whatever? But most likely it's something in slog, and so I'd be inclined to put it there.
Start. And want to increase the granularity on this or anything, or is this fine for now?
I think this is good, just to as a first range shot.
Okay, but then I think all we should need for this is just to build areas, and then wait, we need to rebuild the we looked at the other one. But it is getting to slog start.
It is not getting to slog end.
It's not getting slog.
Okay, that's good. We have a boundary now.
So let's see. All right, should we hop into the newt, or should we see if it even gets to the newt?
Yeah, I would put a printf right before that call, right before the line you're on, like inside the if statement, to make sure that it's actually hitting that case. Like, because I wouldn't be surprised to see that error if we actually printed, like if we did print line, because print line goes to std out, and the king is gonna.
Oh yeah, this
is weirdly.
This should be an ePrint line. Yeah, this is.
I think it should be ePrint line no matter what.
Yeah,
but
that's just a bug, right? Because it's newt always talks on standard in and standard out.
Yeah.
Okay. So then back here, or the build. Back over here. Try running it again. Slug hit. Okay.
Okay. Okay. So that was a bug, but not the bug. So now, can we find that slog function?
This is in. Oh yeah, it's in newt. Right.
Where does not come from?
Not is. Let's do this. Some not equals newt, because newt might be an
option.
Gotcha.
Yeah.
But
okay. Yeah. So that should be in here. Yeah.
Hey, I forgot I had this.
Yeah. Okay. So
pass log print priority. Sorry, priority and what is the priority for a slog?
If it's 0, it gets printed gray. If it's 1, it gets printed one of the colors, the traffic light colors. I don't remember. Red, green, and yellow are 1, 2, and 3, or 3, 2, and 1.
That's just the color.
It's yes, it shows up as just the color. In theory, it could be used for to get piped to different files or something, but it only actually gets used for color.
Okay, so in slog we already have this inside slog, or I guess we could do starting slog, ending slog, and then up here we have surf writing noun, surf done writing noun. And we print out what the noun is, which will get quite pretty printed. All right, let's try that.
Yeah, this is worth trying. It's possible that it'll print something huge, like sort of earlier on, which we'll deal with if that is the case.
You're right, actually. Well, I think that might be the first slog. Oh yeah, there's going to be a write. Yeah.
All right. Well, we're getting to we're getting to writing noun, but but nothing further than that. No, yeah, we're not getting to surf done writing noun, whereas like the previous one, the ripe one, does. Okay, so that narrows it down further.
Okay. So we have jam, size. So let's see if the jam succeeds. Turn this off
Yeah.
for now, or at least oh,
Yeah, I would just like sprinkle a few here. They're just kind of like,
yeah.
you know, writing down 1, 2, 3, and just like, yeah, the jam I wonder about. I wonder about that vec allocation.
So right here.
Yeah.
Well then, let's check the size as well then.
And then sure, yeah. The
Then
copy non-overlapping, you know, should be fine, but that I would definitely check after that. Maybe after the whole match because they both do copy non-overlapping.
okay. Uh, so sure. On the left, left,
Yeah.
on the right. Anything else?
And no, yeah, that's it. Yeah.
All right. Let's try this out.
Maybe allocation of 21 bytes. Oh wait.
You
I
see
mean,
something?
continue, but I think that what's happening is we turned on the assertion for allocations, and I think we're allocating.
Oh, right. We might be allocating on the actual Rust heap instead of just getting memory and throwing stuff into it.
Yeah, I think that's what's happening.
Okay.
It'd be worth finding out where that is. So right, so serve buffer size. It's that vec line, isn't it?
That was We didn't check anything right before that, so let's quickly confirm that.
Well, my guess is exactly that line. I would put a printf immediately after line 88.
Mention Adam.
Because I mean it certainly looks like a heap allocation because it's dynamically sized.
Allocation. There it is. And down. Yeah.
Yeah.
Looks like it does not get to. So this is where it fails.
Right. Because we're allocating this buffer. Why are we allocating this buffer? Because we need to pass
This
this
is the
buffer
buffer that we're.
to write
Yeah,
all.
this is the buffer that we're going to use to send through the wire.
Right. Okay. So then.
So at the right. Yeah, right.
Right.
So this would need to be on the not stack, which we have
Well,
here.
so we do have it. We can just do that. Is it true that it needs to be on the knock stack? Let's see, because if we're here, we're writing it down to the new. That means we're at the top level. Do we care in here?
Care about what?
Oh, because we're
elaborate?
we're writing to we're writing to Newt, but we're not really at the top level. Like we're inside the interpreter, inside a hint handling. And so like if this died for whatever reason, like you tried to print something that's too big or whatever, that should just kill only this thread. So yeah, we need to be allocating on the knock stack. Yeah.
Right.
Which I think we can just do.
Right. So this buff, you know how to, I think it's size plus 5, U8. So we just want, what is there's a thing for doing this. Where is net.rs? Is, I think, push.
push creates a new frame,
right? But I think
which
we
we
want
probably don't need. I think uh, there's like
which
stack alloc or sorry, struct alloc or something like that,
right. I think
or
that's what it
alloc
is.
something.
Direct alloc. Struct alloc. Struct alloc in previous frame, we want just struct alloc. Yeah. This is actually what we
Yeah,
want here. So we're going to give it that we're going to, we want to go back to mute. We want to do, keep this around for a second. But we want to do stack dot struct alloc U8, and we want size plus 5. And then theoretically, this should be a check add here, but here it is. Okay. Add question mark. I think this is
yeah.
it. So oh wait, but no, this is going to be
Yes, except
to return a mutable pointer C. So do you know if just like in C, Rust has this is going to return a pointer?
yeah. So we can, yeah, we taking that in as a mutable pointer probably is what we want. I think. Where all this
I'm
buff get
showing can
used. Yeah.
then with this will this actually work like this? Like can you
I
when
think
you
it
have a
will.
pointer in Rust? Okay. And then the other thing is, do
It might
we
need to be an
now?
unsafe block, but like probably needs to be an unsafe block. Pointer dereferencing usually does. The other
Right.
thing you could so yeah, so our options here are mutable pointer or a vector, I think. We
Like we could tell it allocate a we could tell it to allocate a vector of this size as the struct that we're allocating. Is that what you mean?
no, actually, the way you would do that is you would allocate it the same way, and then you'd create a vector sort of around it. So the way vectors work in Rust is they're fat pointers. So the so a vector is essentially the data itself in contiguous memory and something like and a length,
So we can
and then also
say then
a
take this
pointer to
pointer and
that.
make a vector out of it.
Yes. And that's called from raw parts, I believe.
From
We
raw
use that
parts.
in various places where you say basically here's the length, here's a pointer to the beginning of it. It's an unsafe function, obviously, but what it gives you is a vector.
From raw parts.
Yeah, or possibly from raw
That's
parts. Mute. I'm not sure what that is, but yeah.
It's coming from slice.
It might be a slice that we end up with. I forget a slice or a vector. Okay. Which the thing that matters primarily is what are the call sites of buff, which
right.
are which we can look at there. But yeah, are you able to like highlight buff? I don't know if you search for buff or whatever. Is it going to highlight all the instances of it or whatever? Just make it easy.
Yeah, it's there's only 2. There's either using it as a mutable pointer plus 5, which is when we copy the data in, and then after that we just write all at the bottom.
Right. Okay. So what does write all take?
Talk about output. What is output? Output is a file. Not sure.
Okay, so that's gonna be
I don't have
Rust docs.
Yeah. This one of the things right now is that the Rust analyzer doesn't work because of the way we have our project set up. So I can't actually just peek at the definition of this.
Yeah, but the browser's good for it as well. So it should be. I think. I mean, I'm nearly positive that it's a reference to. Well, that it's Pam cell U8, whatever that is. I'm forgetting the Rust name for that. I think that's a slice, right?
Pam cell U8.
Yeah, Pam cell U8, Sarah. Like Pam and then in square brackets U8 appears to be what. I mean, there's a lot of write-alls, but they all seem to take basically that.
Rust has response as well. Hoping you could get me this so I wouldn't have to risk opening the browser recording.
Yeah.
Write all. From raw.
Yeah, from raw parts for slice is going to give us what we I think is going to get confused. I mean, there's also a vec from raw parts, so maybe that's, but I don't think vec is correct. I think it's a slice.
I think slice.
I don't
I see what you mean. Off the write all. Now it's a buffer Pam with the U8.
Yeah.
Oh, okay. Now I see what you meant by cell U8. Okay.
Yeah.
It's wrapped in square brackets.
Yeah. Do you remember what that syntax means?
It's a array. It's a reference, or it's a reference to an array, which can be a slice, I think.
Okay.
So I think so. We want a slice.
Okay, so we can do so. Slice has a from raw parts that takes a pointer to data and then a length.
Right. So let me go look at a random one of these again. From raw parts. Okay, non-mud. Okay. Self dot. So what is from raw parts? It wants a size and a pointer. Okay. So if we allocate
actually, it probably does need to be mutable, right? So from raw parts mut is probably what we want. Yeah, because we're about to mutate it.
Right. Right. So we want a. Oh, now. Right. And this comes from. Okay. So copy that. We're going to go back to news. To import it. We only need one.
Yeah.
Okay. And then down here we get our mutable pointer. So actually, I think what we can use directly is buff equals from raw parts one, and that will be that. And then we want size parts five. That look correct?
Yes, except it's from parts mut, not mat.
Yeah, sorry.
And I think it'll infer that the U8 through that. And then that's going to give us something of type basically Pam mut.
Then I think let me double check. That slice, I think slice probably has an aspect rest I think that's what we want to set to the right all.
I think it might just be itself. I don't know that it needs to change at all.
You sure? Well,
I'm not sure.
Where's the slice? use slice. URL, is that real? Not real. I click it from here.
What I'd be inclined to do is just try to send it and see what the compiler says. Like if it complains about a type, then it'll give you some information about what that type it thinks it has and what it needs. Let's see.
Oh yeah, there you go.
Yeah.
All the unsafe functions, right?
Yes, both of those are unsafe. And so I would
both. Which ones are unsafe?
from raw parts and struct alloc. So that whole line, or like right where your cursor is, you can put an unsafe block. Yeah. It's a good example of where like the things inside that are individually unsafe, but nice. Okay. But once that unsafe block is done, actually everything, you do have a safe slice now.
Right. I think that's correct. You might know more about this, but I remember that this came up for both me and Jonathan earlier working on this. When do you use a unsafe block versus an unsafe function? And the idea is that an unsafe function is unsafe, including for anyone that calls it, meaning that you're pushing the responsibility to maintain safety onto whomever calls your function. Whereas an unsafe block is that you're doing something unsafe, but you're guaranteeing that you're doing it correctly within the function, and the invariant of safety is maintained from the start to the end of the function.
Yeah. So here there's all kinds of safety things to pay attention to, like make sure that the sizes actually line up, make sure that the memory that we allocated, which is just this pointer, but that Rust doesn't know much about, that's going to get freed, and we are confident in all that. Yeah.
Right. Okay, so let's have compile. Let's try running Debugging. Hey, we're slogging. There you go.
We're slogging.
Nice. Okay, that's one down.
Nice.
So let's clean these up and then test it out in a much nicer way.
Yeah.
No, actually, I will clean these up later, and I'll just turn them off.
Sure.
This one, and then I will be down here in slog. Yeah. And back in interpret. Here. Let's try this again. Oh yes. This one. But yeah, all right. Every time we click the button, you get a test. Slog test.
Yeah.
Perfect. That is for those watching at home here in the Toddler. It's because every time we click any button, which will generate a input event, all we do is slog test and then preserve the existing state.
Yeah.
Okay. Let me clean up that last one that was in certain copyright. Oh yeah, that was it. These ones. Never did them. Right. Then we can go to author. And all right, so this is working now. Let's try then this one, which should now unify our issues.
Yeah.
All right. So this is going to be fresh toddler. And oh, forgot to try the command. Yeah, there we go.
Right.
Oh, and I forgot to rebuild as well. Get rid of that. Serve copyright. Okay, so now these I believe are coming from error messages I put in. So we have a starting point. This should be
Okay. Yeah.
in the knock jets in the move utility. I believe I'm somewhere. Did you get that, Phil? Just got hit on the head by a leaf.
Oh, I didn't see it.
I think it's somewhere here. Not two. Is it actually coming from there? Interpret. Oh, okay. This is where I had it. Right. Okay. So we are calling Mook, and we then are also mapping the result if it is not an error. Check if it's a cell. So that's why we have this OK tune. And then if the tune head is not a 2, that means that something went wrong, and we return none and reprint this.
Yeah. Right, because the tone we're passing in definitely starts with 2, and Mook is supposed to produce something that starts with 2, and it doesn't appear to be doing that.
Here's where the tone was generated. Here's our stack from the getting mean stack, and then here's the 2 we put in.
Right. So you could either just print out the whole tune at that point, or we can dig into Mook.
That's a good point. So it is returning something.
Right, it's returning something. I'd be inclined to print out what it's returning, just like print out 2
Yeah,
and see what.
Let's take a look. What is it actually putting out? 2 not 2. Actually, just do it this way. All right, let's take a look. What is this? Probably Phil. All right, so it's one of these.
Right, so we're getting like a leaf or like a whole tang or something. It appears,
We are
but
getting a whole.
it's just not. It doesn't have a 2 in the front of it.
Yeah, we're getting a list. It's not returning. Okay, I think that might be the issue. Maybe I'm just not returning anything. So let's go into knock. And how is this? So we have we get this. We have our tag. Confirm that's 2. If flop. This one is that some hints flop the stack trace. The regular stack trace when you have an error is not flopped. This makes a difference for now because a hella hint is the only thing that we're testing to. This move is not hooked up to the actual tree walk interpreter right now. So we don't have working stack traces, but we should have working hella hints. The hella hints do flop the stack trace, and before we can implement this other version that does not flop it, we need a deferred cell allocation like we have in there with DEFCONs, which we don't have right now.
Deferred cell allocation. What do you mean by that?
Right. So like I want to handle converting the list of the stack trace in a tone to a tune. So, but I don't want to change the order. So what I want to do is, okay, I look at the first item, mirror it for you. I look at the first item. I want to convert that to a tag from a stack trace, but I know that the list isn't empty yet. So then I want to say that, hey, I'm allocating a cell right now, but the thing that's going to go into that cell, I don't have that object yet. So let me allocate this and then like reset what the result is and then change that. And then like keep doing that down the line.
Which we definitely do that in some places. Pretty
Do
sure.
you remember off the top of your head where?
I'm nearly positive. I'm trying to remember where. Like, but it's just like I remember seeing that pattern. Um, it's like, yeah, new raw mutt is the function that I'm thinking of. Where it,
New raw. That's in noun, right?
yeah.
New raw. Make an indirect atom be written atom. Hey, yeah, this is it. Interesting. Okay.
So this is the indirect atom version of it. I think there's also a cell version of it.
Right. Going.
But we're saying I want to create this, but it's still marked as unsafe because it doesn't initialize anything.
Right. Hey, yeah, this is it. Okay, perfect. Did you write this or did Ed write this?
I think Ed wrote it.
Okay.
Or yeah,
For
no,
Ed.
he wrote
For
it.
Ed. I said for Ed because I checked with him and I don't think he remembered that he wrote this. Or maybe he didn't understand what I meant. But he's written so much and rewritten of this so much, it's absolutely understandable.
Yeah, this code is at least a year old. Like the fact that that's in there, I'm pretty sure. Yeah.
Okay, perfect. So then that saves work for me, and I can use that. All right. So then when we do come back to this, I can write the unflop version down here.
Yeah.
Right now, just destroys the trace. So this is the thing. Okay, we have OK res. I think that's the bug right there. We need to res should be called something else, but I'll change the name afterwards. This will be res the stack, and then we want two. Yes. Res should be called like trace. And then let's return this. And this one, let's return stack. Okay. And hopefully that's it.
I think so.
Yeah. Remember what I did on this one. All right. Let's try this again. Oh. Hey. All right. So it's failing, but it is printing stuff.
Yeah.
Spot. I am indeed. Oh, move spot. Okay, that's an issue. That means it's not handling something correctly in here. Move spot is what happens when. Whoa, sorry, the mouse goes. Did I manually make that? Yeah. All right. So, okay, it's not matching the in. Eight. 8 equals rip stack 3. That means it's not matching spot here. Why is it not matching spot here? Tag as Adam. So what's happening is it's getting here. It's not matching this. It's going to the default case, which is just move dot print, I think. Let me double check that though. Sorry, dot spot. Oh wait, here, no, it could be this. If the formula in DAG crashes, we produce move dot spot. Okay.
Okay, so something about the formula.
I'm glad we're getting here though, because I had to write a thing in here. Where is it? A tape to noun thing, which did not get tested at all. So it's good to see that it is working. Because I'm passing in a tape here,
right,
and it's being correctly made, and it's able to be solved.
Nice.
Okay, so tone, if unsafe, tone.head.raw equals here. So this is the tone that we get from a jet main. Okay, so what is this tone then? So let's go back to the interpreter. Let's delete
Yeah.
this one. We can bring this one back. And then what is the... Actually, that's not true. I'm going to turn off my video for a bit and move somewhere that has power outlet
Sure.
in a few minutes. So we'll have to pause for just a quick short 10 seconds.
Yeah.
Okay, so we'll keep this one around because this one had... Or when it failed. Oh, but we stopped failing. Right. Okay. In that case, yeah. I want to see what the leaps that were being printed were again, but I think we are printing them now, and there's no point. The leaps are being printed. We're just moving spot over and over again. But the mean hint is also being handled, so that's good. All right. So what do you think? Just dump the tone here.
Yeah, the tone and maybe the subject as well. Or unless the subject's too big.
Let's try it. The subject is just the subject we do want to see. We want to dump dat, actually, not the subject. The dat is the formula that we're supposed to run. That was the thing that we had that call where we realized that it passes a formula to run on stack, in the stack trace on failure, which gets handled by the Euclidean soft while handling the stack trace. So that's what that dat is.
Okay, what I'm confused about.
Remember?
Okay, what is subj? Like there are three items in that. Is that subject formula in like Scrygate? Is that what it is?
No, that should all be the data, I believe. Maybe it's not. Maybe that's where I'm going wrong. This is when you jet Mink, what it's going to do is it's going to assume that this is the subject for the entire formula. This is the sample to Mink, and then this is the batteries. And so because I didn't want to pull out the logic,
battery.
I didn't want to pull out the logic of Mink.
Yeah.
So I just reused jet Mink. Which meant I had to create a fake subject and a fake battery.
Yeah. Okay. Yeah, that sounds correct. Okay. So so dat is the one that we believe is the subject and a formula. Okay.
Actually, let's get them on separate lines. That equals that, and we'll do tone equals and then sorry. Tone 20. Okay, so we're getting a null result. And the dat equals lit over 0. That's the file. These are the. This looks like a correct. Oh no, this is just
that's
a
not a
raw.
formula.
No, that's just a raw.
Wait, because spot you don't actually run anything, right? Spot is actually it's like mean that you mink things, right? The spot you just soft the spot and then do it. Like if you look in the MOOC in Hoon.Hoon versus mean, they're like the spot versus mean in there.
Spot, we call soft on spot, or soft spot on the data. So I guess this is just casting it.
Soft is not the same as Mac.
Right. Sorry. So we're just casting it. We're just assuming that it is of type.
I mean, we're checking that it matches the type we expect it to be. That's what soft is doing.
Yeah, that's what we're doing.
And then if it doesn't match that type, then we print mook.spot. Otherwise, we say, okay, now I know where everything is.
Right.
I know what axis everything is at, and so I'm going to print it out in a bespoke manner.
Right. Yeah. Okay. Sorry. I think this is what confused me because we're not quite doing the same thing as Bear does. We did the wish harm. So when I was inspecting what soft does, I think I forgot that this is the input to this is not we're not macking it. We're just I think there's another place where I do this correctly. I think in here where we like this one we mac,
Yeah, that one we do
but
actually Mac. Yeah,
we also do a
soft
soft bank in here.
is easy to mistake because if you look at the definition of it, you're like, oh, there's a mule there. Okay, so it is running something virtualized, and he does need to be
Yeah,
unique or something like that. But the mule is not for it's not running dat or something as a formula. The mule is just saying, does this clam operation, like this validation, does that itself crash? Which we
right,
don't need to do in the same way.
right. Okay, I might lose connection here for a second, so I'm giving you a warning that
Yeah.
maybe we want to pause recording and then cut this part out and just do a quick edit.
Okay.
Right after you said that. Let me quickly move over for you guys.
All right.
But,
Yes, I can. You sound fine.
Okay, I sound fine. How's the background noise?
Background noise seems okay. Yeah, there's a little bit, but I don't think it's a
Okay,
problem.
I'm trying to turn. Can't stop. Maybe it's the video chat app. I need to be able to tell it to stop adjusting my microphone volume. But I want to just pick it and lock it myself. Maybe that's in the settings here. So.
Yeah, that I don't know. There's a bunch of things along the line that are all going to try to
Yeah,
control it.
we'll just do it for you. Urbit fixes this.
There's one in Video Ninja that I can turn off. Auto
Can you
gain
try that one,
control.
please?
Yeah, or it might bring something up for you that you have to click, but like, yeah. So I tried that.
Okay, it seems to be working. Yeah, it stopped adjusting for me. So can you still hear me okay at this level?
Yeah.
And is the background noise better?
Yeah, it's not bad right now.
What if I do this? How's my volume?
Sounded the same to me.
Even the background noise?
Yeah. I mean, I think the background noise is pretty quiet, so it's hard to tell if it changed much.
Okay. Oh, okay. That's good. And you seem to have a decent headset, so probably means it's great.
Yeah, I mean,
I think I can reduce.
it comes and goes some, but yeah.
Okay, I think I can reduce it a little bit more by giving myself a less comfortable experience.
Okay.
I just closed the window, so now I'm sitting in a basically sitting in a greenhouse in the the middle part between the continents of North and South America.
Nice.
Okay, so let me try sharing my screen then, and will that still have a good signal? Because
Yeah.
I moved away from good restaurant Wi-Fi, very good restaurant Wi-Fi, and I switched to my phone's data plan, which is good, but it has spikes.
Yeah.
So let's try again, entire screen, share, and then let me move over to something else. How's it looking?
Yeah, not bad.
Not bad?
Yep.
Okay, so then let me know. Give me a countdown, and I guess we'll take it from where we left off.
Yeah, we'll go ahead and start now.
Okay, cool. So we were accidentally, well, I was accidentally, I should say. I got confused about what I should be doing because I saw the mule into a Muir, into a mock, into a mink, and decided that I need to be running mink on this. But I don't actually need to be doing that. I need to be verifying that it is a spot type. But we kind of do that on our own in here by just checking that the form is right. Like, is this a cell? Is that an
Yeah.
atom?
Yeah, exactly.
So it seems then what we really need to do then is just, I think we can just delete all of this, wrapper around this, and just go straight into this. Does that look right to you?
I think so. Yeah. And just like spot will be dat essentially.
Yeah. So I'm going to do this, and then in the interests of, I'm going to do let spot equals dat, and then just comment this out. And I think comment that out. Move this one down. This should just be it. I think I did one extra here. Right? Text equals format. No, it wasn't this that was extra. It was this. Like that. Maybe tape equals. We're gonna use this. I think this. Yeah, everything except that first part. This seems right then. And then we have the rows. smite fin, and if we go back over here, we've got our rows, smite, and fin is just what I called this.
Yeah.
So let's try that, and let me head over to the terminal. Spot head, not down to now. Spot.
So I
Spot
guess it's
equals
that dot
that.
as cell.
Oh, we want that as cell.
Yeah.
Right. And this will need some cleanup, but oh, memory
Yeah,
allocation.
we might run into that. Okay, so we got to
You
see
know
where we're
where?
allocating. I think format might do it, but there might be some other ones before that. I would sprinkle printfs until we find what is allocating.
Interesting. Let's see.
My best guess is format right there.
Yeah,
so I
let's
definitely put printf before and after that. But
instead of text equals this, let's just do a test like this. I'm going to change text to be something else. Let
sure.
text equals ABC. Let's try that. Oh yeah, that's fine.
Yeah,
Those are
that's
optional.
fine.
Okay. This is SERP error need to code. That's now
That's somewhere later, at
in
least.
there. Yeah. So it is
Yeah.
definitely in. It is this format.
Yeah, it's either call to format itself or the interpolation or which I guess is inside the call to format, or it's uh, these arguments. Can we try it with these arguments commented out and put specific like
Oh, sure.
literals there
Just
as
double
well?
check.
Yeah, make sure that it's actually
Sure.
the format one.
A, B, C, D. Right, let's try that. Oh, whoops. This one might be the cause of that failure, by the way. I'm not actually scaling the numbers so they don't have dots in the appropriate places. But
Okay.
we'll see that later.
Yeah.
Yeah, it is the format.
Okay. So what are we trying to do? We're trying to create a string that looks like that.
Yeah.
And so we're gonna need to do that like somewhat more manually, basically.
Right.
Do the arguments themselves also allocate or not? It might be worth trying one, like they're all doing the same thing. So if you like try one of them
Right.
above it,
Try it like this one just straight
to,
and then just, yeah.
Yeah, just like set that to something above so that we can see if that's causing a problem.
This one is piece dot head. Let's try this.
I don't think that's gonna type check. Like it needs to unwrap the either and stuff. I would just
Right.
the whole 4 lines or whatever. Is probably what I would do.
Like this.
Yeah. Yeah.
Yeah. Right. Okay. Yeah. Looks like this allocates too.
Okay.
So two string allocates and format allocates.
To string. Where does that? Yes, Adam. Yeah. I think we could probably fix the to string, right? Where's that coming from? Like, where's that
To
defined?
string?
Yeah.
Like that's a U64. That's a language definition thing.
Oh, to string itself. Okay, then yeah, we need to have something that'll turn a U64 into.
Or I guess
Wait,
what we need is
what do you mean
we
by?
would define this. We would well right now I'm getting the data and I'm getting if it's an indirect atom the number as a ubig and then I'm calling to string, so I'm letting Rust do everything. So what I guess we want is we want atom to have a to string method which direct and indirect atom can utilize or I guess expand on, overload. And then those should create strings in a non-allocating way.
Yeah. So right, because so Atom has like a an implementation of format display, but my guess is that allocates. Let's see.
What was it called? What was the name of the function in Atom?
So in Node.rs, if you search for FMT : display with capital D,
format. Right.
yeah, it's these ones that show up, or that we have implementations of those for various of these types. But I think
Do you know
that they allocate.
Yeah, I would imagine. I think F would be the formatter here, which would mean
these are
whatever is
really
in that
meant
format
for displaying to screen, which we're gonna have to figure out. Okay, I think what's supposed to happen here is that we write versions, we write functions that display these, but don't allocate, or else only allocate on the Nox stack, and then sort of this should call that function, because this is just implementation of a trait, so that you can print it out in like printfs and stuff.
Right.
But I think it's going to be a little more complicated, because anything that needs to allocate anything has to do it on the Nox stack, and that means you need the Nox stack as an argument. So
okay,
we may need to
okay. So the two string thing,
display trait for now. Sorry, go ahead.
Do we actually want to do a version of the display trait that allocates on the Nox stack, or do we want to just generate, like, is this like, this is kind of a means to an end, because the reason we're ending up with string is because I want to throw that to tape. What we really want is we want a tape containing the data. So maybe what we really want is just to go straight to that, or we have some sort of like,
I would build that
build our entire own formatter. Yeah.
The thing that's going to be really annoying is that we want to like print out a noun or something like that. You're not going to be able to do it if we're inside of somewhere we're not allowed to allocate. But we'll deal with that in whatever way we decide is most convenient. Which for testing, very often is probably just going to be wrap the printfs, the eprint lines, with the whatever function it is that turns off the no allocation assertion. But we can ignore
Sorry, can you repeat that just so I follow you? You want to do a version where we would temporarily turn off the no allocation thing, create a create like an atom or whatever, a tape after using string as a helper that allocated, deallocated, turn the allocation back off, and then return that now. Is that what you're saying?
Yes, I think that we will want a version like that, so that we can eprint line nouns, like, because we're gonna be needing to do that. But I don't think we need to do that right now. I think we need to do right now is build a version that pretty prints and doesn't allocate, or however much we need for this MOOC stuff, because that's sorry, not doesn't allocate, only allocates on the knock stack. And yeah, I don't remember how much we need of that for MOOC, but we're gonna want a whole system like that.
Yeah, it sounds like we kind of want both of these things, because the one we want more long term is not the fastest one. So I'm writing it down just to summarize here. We need a version that either A, allocates on the knock stack directly, or for creating a tape, or even a string, because we might want that. But then the other thing we want is disables no allocation, creates a string, utilizes it. So that would be either printf, printf, or generate tape, and then deallocates. So okay,
I mean, it doesn't really matter if it deallocates. Right? The purpose of that one is to be able to just eprint line something.
I think we wanted to deallocate because otherwise, isn't that a memory leak? It's gonna, since Rust is kind of not expecting.
It's a memory leak to allocate at all, because you might get killed in the middle of it, and then you're just gonna
but I mean this.
But like, but Rust is gonna automatically deallocate most of the stuff you need. Like,
yeah, that's what I'm asking. Is Rust going to deallocate stuff that was allocated in between a turn off, no allocation, turn it back on? Like, is that just stopping it from allocating in the first place, but it will still go through its regular checks of deallocation?
Only if, like, you finish the function, yes. Like, if everything goes normally, yes. But if that thread gets killed, then it will not.
Right. By thread, you mean like an actual thread process in the future, or do you mean just like a version of Make?
I mean, like an actual thread process that we're gonna do. We're gonna run knock computations in their own thread, so that that's how we're planning to handle non-deterministic errors. Is that you kill the thread, even if you implement it with long jumps or whatever. If you long jump in Rust, it's not gonna be able to deallocate anything.
Right, but it's not going to be able to deallocate anything in its own thread, which shouldn't matter, because then that gets killed, right? So like the thread gets killed, that memory entirely gets given back to the system, and it never allocated in the PMA because it never finished because it died. So that memory leak doesn't actually leak memory. Am I understanding correctly?
When the thread gets killed, I don't think it gives that memory back.
This thread is going to be a child process of the parent. So is it sharing
not a process
memory space? That's not a process.
Yes, it will share a memory space.
Oh, okay.
Not a child process that would have its own, because we want to share like the whole loom and everything. Yeah.
So then, is B something we want then, or should we only have a? Or I guess it's okay to have it if it's like a debugging tool, right?
Exactly. What we want is the ability to say, "Oh, look, I have a noun. I want to eprint line this noun," and like that can get implemented several different ways. It's possible, like this may or may not be the right way to do it, but it's one way to do it that I think is fair, as long as you're only using it for debugging. It's possible that it's better to actually, don't use the Rust display system at all and create your own replacement for it that uses their own allocator. Like there's, yeah, I don't know what it'll end up being, but what we want is to be able to to easily print nouns. And there's lots of ways to do that. So what I'm imagining, the reason why I think that this is an easy way to accomplish a B is that it doesn't require us to do anything, except that when you're calling ePrint line, you just you wrap that with whatever the name of the function is that turns off allocation, and that's it.
Right. Okay, I think I see that makes sense because it's quick, it's easy, it gets us unblocked, and I believe that was another one of the areas mandates, right? Whenever possible, write debugging tools, and this would definitely be a debugging tool.
Yeah, or I mean, even it's really basically just like a pattern. Because it's just, call it with permit alloc. It appears to be the name of the function. So when we write an ePrint line and it complains, oh, I can't ePrint this thing because I just allocated and I'm not allowed to do that, then your instinct should be, oh, I'll just go wrap that in a permit alloc because this is just debugging anyways. And that gives us the second thing, which means that the thing we need right now is build something that's like a pretty printer or however much we need from Mook, but doesn't allocate on the Rust allocator.
Okay, so for now, you do want to write a version that just doesn't allocate on the Rust allocator.
Yes.
Okay. So going back to this, just trying to think what would be the best way to write this.
Let's see, so what do we need to print out? This is what we care about is we have atoms which are either direct or indirect. Is there anything else that we're printing out?
No, I mean, they're all numbers. So what really we could do is we could call rip. We could add that like +0 or whatever that we did earlier, like we did here in Toddler, to each of them. And then this will make a tape.
Yeah. Let me think. Basically, we just want to do, Scott send UD of an atom, just like write that as a function.
Right. I mean, yeah, we could write that. That's basically the same thing. Just every 3, get the length, and then every time it's mod 0, inject a dot into the tape. Yeah, I can write that.
Yeah. I mean, like that's precisely what we want here, basically, and then we can abstract that in any number of ways when we have more call sites for it.
Right, and then I was also thinking that if we write a version that's doing like this sort of formatting, it's this one doesn't quite work as nicely, but it's almost like writing a rows, which we might end up using later.
That's true. It's not quite a rose because of the other dot.
It's not quite a rose. Yeah, this dot kind of ruins it, but aside from that.
Yeah. What I would do is basically just write exactly the thing that we need, and not try to abstract it because there's 1,000 ways to abstract it. And I don't know that, a general string interpolation thing is worth it, or that much of anything is worth it other than like, okay, Scott send UD is probably useful, but like basically there should just be a function. Like the way I'd be inclined to factor it is you have 2 functions. One is Scott send UD because you're just going to call it 4 times here. And then the other is stick them together. And this might just be inline here, but stick them together with the prefix gal and cell. And then the first one, then space, and then the second one, then space. Like I wouldn't take any of those as arguments or whatever. It'd just be like, I'm going to stick them together.
Yeah, I can write exactly that. It might be. I was wondering, like, do we want them formatted exactly like this, or do we want them just? Do we just want the information to be printed? Like, this isn't any sort of standard. This is just how the pretty printer will print out a stack trace right now in var.
Yeah. I don't know that it has to be exactly the same, but do you have any better ideas?
As long as we convey the information, does it really matter if we do so in a bit of a different way?
Why? What are the ways preferable?
Just whatever will get us this faster than having to worry about, like, oh man, like adding this dot here really makes it annoying. Or like, all right, we saw the numbers, and now we have 4 strings, but like hooking them up generically is easy. It's just go through each time, and if we see a data which is a 0, we just replace it with space each time, unless it's also the final. Like if the list is over, then we know, oh, actually this is the end of the string, the end of the tape. So forget it. So if we did that, we would end up with something like this. That's not exactly what we're printing, but now like I can write that in 5 minutes, and we don't waste a bunch of time trying to, oh man, let's really replicate this exact string here.
Yeah, if that's actually easier to write, then go for it. I'm not really seeing in my mind why that's easier, but if it is, go for it. Absolutely. It's very straightforward to come back and clean this up later. Yeah, go for it.
Yeah. Okay, perfect. Cool. In that case, I guess that's it. Yeah, the biggest thing was that we figured out that, yes, I made a mistake up here. Got confused with us running math on the spot hint dynamic formula, and the other one, which is these are allocating. But we now have a plan for that.
Yeah.
Any other loose ends?
No, I think that's it. Yeah.
Okay, cool. That was good. That was a really good session.
Yeah, I think so. All right. Then I'll go ahead and stop recording.